Derivative.
Are they ones you can verbalize?
Yeah, here. Let me pull one out of my book.
If they're simple functions, then you can probably verbalize them fairly easily.
Yeah.
And we'll just do them.
Okay. So hold on. Give me 1 second, David.
Okay.
All right, David. I'll have those problems for you in like 1 minute.
That's fine.
All right, David. So I got the pages here now. Okay. So so a lot of these are. So it's like. Okay. So actually, I'm gonna mail this to you because there's some other problems.
Okay.
David. Okay, here we go. It's in my recents. There we go.
It's that right there that you see on my screen.
Yeah. All right, I've just mailed it to you.
Okay. Boy, that is a number for a JPG file. Look at how many digits are in that number.
Jeez, I know. I don't know why that happened.
What the heck? That's strange.
Yeah.
I've never seen a number that long for anything.
I know. All right, so like number 1A, how would we do that?
Okay. Let me take a snapshot of this so I can write on it. First question. What's the slope of the graph at that point? Well, that blue line right there is the slope of the graph at that point. What is the slope of that horizontal purple line?
0.
Okay, that's the answer. Now, let's estimate the slope at that point. And let me erase what I just drew because that's not helping any, but it's the blue line. Figure out what the slope of that is. It's just an estimate, but it goes from there to there. Looks like it goes up 3 and to the right maybe 1.5.
Yeah, looks about right.
About 2 maybe?
Yeah, sure.
I mean, if they'd have really wanted us to give them a good estimate, they'd have put this point on a grid corner?
Yeah.
They didn't. So they obviously don't care how accurate the estimate is. So that's a reasonable estimate. Okay, looking at B. Let's just.
Oh wait, hold on. Hold on. For 1A, for 1A, we're finding the slope of the curvy line, right? Not just the horizontal.
Yes, but hold on. They're the same thing.
Okay.
In other words, when you say the slope of the curvy line, you mean what is the slope of the tangent line at that point? Well, the tangent line is that horizontal line. So the answer to the question really is, what is the slope of the tangent line? In fact, I wish I had put that in there. It's the slope of the tangent line at those points. That's what they mean. But that gets interpreted to mean that that's the rate of change of that function at that point also. In other words, if you want to look at it as derivatives have to do with rates of change, well, the function isn't changing at all right there.
Yeah. Okay, so I understand.
It was going up, and now it's going to go down, and right there it's dead still. So no rate of change, slope is 0.
Yeah, okay. Can we go on to number 4 now?
Sure.
Okay.
Does this have to do with, that graph? Okay. Well, the easiest way to do number 4 is to fill everything in. In other words, I think that's what it's all about. What is f of 4? If you go up to the graph, find the x-coordinate of 4, what's the y-coordinate?
Oh, so it's 5 minus...
Hold on. 2. That is f of 4 is 5. Let's just start there.
Actually,
now what's f of 1?
David, we don't even have to do those problems. I just didn't understand what he was asking, but you saying that just made me realize, so we're actually good on that. So let me find another problem we can go over.
Okay.
Okay, so like, I'm going to send you another image.
Okay. Curious.
All right, I sent it to you.
What kind of camera are you taking this with that it gives you a 25-digit identification number on that image?
They're actually screenshots sent to me from a friend.
Oh.
So I don't know.
Okay. I don't think I've ever seen an identification number that was larger than that.
Yeah, I don't know. Okay, so number 11 here is what I'm looking to do. Or any of those in 11 to 24, where it says find the derivative.
Okay. By the limit process, it changes everything.
Yeah.
First of all, have you learned the power rule, product rule, quotient rule, chain rule, any of those?
I don't know if I have.
Well, those are the easy ways to do this problem.
Okay.
We're going to do it the hard way.
All right.
So here is the definition of the limit of, or what the first derivative of x is equal to, is the limit of f of x plus h minus f of x all over h as h goes to 0.
Yeah.
Now, First of all, this is the hardest way to take a derivative. Why they start you off teaching this, I'm not sure, but they do. Everybody does. So you have to get through this section where you have to do these problems using the limit process. These problems are all, this limit process is going to take me 10 minutes or 5 minutes. I could do it in 10 seconds if I use the easier method. But they want you to understand this method, okay? So what we're going to need is f of x and f of x plus h. When they give us f of x, we're looking at 11. What is f of x plus h?
Good question. I don't know.
Well, let me give you an easier problem, first of all. This is a tough one to start with, even though it's number 11. If I said f of x was x squared, what is f of 3?
9.
What is f of x plus h?
Oh, it's just x plus h.
Squared.
X squared plus h, that's what yeah.
In other words, the secret, whenever you have something in the parentheses other than x, you substitute it in for x wherever you see x.
Okay, yeah, obviously. So,
Okay.
Sorry.
So this one's a little strange in that there's no x. But you can still have y equals 7. That's just a horizontal line. So when I substitute h in for x, because there's no x, f of x plus h is still equal to 7. So it's a bit of a trick question. Okay. Now let's plug it in. This is not helpful in the way of understanding this, but nonetheless, we'll see. Well, that's the limit of 7 minus 7 all over h as h goes to 0.
Right.
Which is 0 over 0, which is indeterminable. Do you know what this first derivative actually is?
I don't even know what you're asking by saying that, really.
Okay. It's 0. When you take the first derivative of any constant, it's 0.
Okay.
Okay? Now, I'm not, this problem actually puzzles me a little bit, even though it's probably very obvious. I've never seen a problem where you had to use the limit process to take that derivative. What they teach you, I'm going to teach it to you right now.
Yep.
Just because you're going to get it pretty quickly. Power rule. If y equals x to the 4th, then y prime equals, you start with the exponent, and then you subtract 1. Got it?
Yeah.
If y equals 3x squared, what does y prime equal?
It would be 2x cubed.
Actually, start with the exponent, but then you got to multiply it by that coefficient, so it's 2 times 3, and then subtract 1 from the exponent, so you get just 6x.
Wait, so, hold on. Why wouldn't it be 6x to the 5th?
Because you're always subtracting 1 from the exponent. In other words, I got from 4 to 3 by subtracting 1.
So you just move the exponent to the coefficient and then make the exponent 1 less than it was?
It's that simple.
That's how you find the derivative?
That's how you use the power rule to find the derivative. Now,
okay, let me write that.
let me give you another one. Might as well teach you this because it's going to help when you go to solve these other kind of problems. But let's do a harder one. Let's do this one. What's y prime? Start with the exponent, multiply it by the coefficient, and then subtract 1 from the exponent. That's the formula.
Yeah.
So it's minus 2 times 3.
Minus 2 times 3 would be negative 6.
Subtract 1 from the exponent.
Negative 3.
There's your answer.
Okay.
That's how simple the power rule is. Now,
Okay.
if I wanted to give you the hardest possible way to solve this, it would be this way. Okay? So, just to make sure you can do one this way, let's do another one, but not one that's a constant. This process doesn't make any sense when it's a constant. So we're going to pick another one.
Hold on. Wait. So you went from the original equation. Can you undo your erasing any chance? Or just maybe put back what we had? Can I just ask one more question on that?
Sure. If that's the original function, y prime is what?
Is 4x cubed.
Okay.
But then what? The one that you did with the negative 3x was like different.
That one.
Yeah.
Start with the
Like
exponent, multiply it by the coefficient, you get negative.
Oh wait, we didn't do that in the other one.
Yeah, we did. Every process using the power rule starts with the exponent, multiplies it by the coefficient. In this case, the coefficient was 1. Okay. And then subtract 1 from the exponent. It truly is that simple. Every single time. Okay. Now.
So I'm going to recite the power rule to you and you tell me if I'm right or wrong.
Okay.
So you multiply coefficient by exponent, and that's your new coefficient. And then subtract 1 from exponent, and that's your new exponent.
Yeah, I'm going to make it easier for you. Let's write the general equation. The general equation is a times b to the x. The derivative of that is x times a times b to the x minus 1. It's the way you always do it.
Hold on. X to the a, b to the x minus 1. Okay.
Okay. Now let's take one of these straightforward ones and do it the hard way. And the one I want to do that makes more sense is this one right here. Okay?
Yeah.
So let's do this by this limit process. Okay, well again, the limit process requires you to know f of x and f of x plus h. So let's list those over here. F of x is minus 5x, correct?
Yeah.
Tell me what f of x plus h is.
It would be negative 5x plus h.
Let's just first of all substitute it, and then we'll worry about it after that. Okay?
Yeah.
So now we have f of x plus h and we have f of x. So let's substitute into this general format here. So what we're doing is taking the limit of, well, if I distribute this, I got minus 5x minus 5h, correct?
Yeah.
That's what that is. And then I'm subtracting the original function, which is minus 5x. Then I'm dividing all of that by h, and I'm going to take the limit as h goes to 0. Now, simplify the top.
The top?
In other words, I got a minus 5x there, and I got actually a plus 5x there.
Yeah, you just have negative 5h over h.
Exactly. Now simplify that.
So just negative 5.
So the limit as h goes to 0 is negative 5 because the h isn't there anymore. It disappears. Well, now let's go back and use the power rule on that. In other words, that was the hard way to do it, okay? But we got the derivative. The derivative was minus 5.
Right.
Well, if we use the power rule exactly as we talked about doing, I would start with the exponent, multiply it by the coefficient, subtract 1 from the exponent, and anything to the 0 power is 1. So the power rule tells you that if you have a linear function, the derivative is whatever its coefficient is. So I got to minus 5 in 2 seconds using the power rule. Using the limit process took me a lot longer to get there. And trust me, it gets harder the harder these get. Although we should do at least one more by the hard technique, because theoretically you haven't received the power rule yet. Calculus insists upon teaching it this way. I don't know why, but they do, so you kind of got to live with it. I'm going to make up one that's a little harder. Is that okay?
Okay. Yeah.
Let's take the function just a little harder. And I should define that as f of x. In other words, you know that f of x and y are interchangeable.
Yeah.
So, first step is always to figure out what f of x plus h is. What is it?
So it'd be just x squared plus h?
No. X plus h quantity squared.
Oh, yeah.
And notice that is not x squared plus h squared. That is
right.
X squared plus 2xh plus h squared. Okay, so now we go into our definition, and we got the limit of this whole thing, x squared plus 2xh plus h squared minus f of x. Well, f of x was just x squared. Always dividing by h, and I'm taking the limit as h goes to 0. Again, what happens in the top? What cancels?
So, hold on, let me look at it. So
you got an x squared and a negative x squared.
Oh, I didn't see the squared part. Yeah, so those would cancel.
Those cancel, and this always happens, is that every term that does not have an h in it cancels. Always, 100% of the time. So notice that the only two terms I'm left with in the numerator are those two. And I can factor an h out. And once I factor that h out, I'm left with 2x plus h all over h. These h's cancel. And now tell me what the limit of that is as h goes to 0. What's the limit of 2x plus h as h goes to 0?
limit of 2x plus h as h goes to 0 would be like 2x.
That's it. Now use the power rule on that original function. What's f prime of x equal to? If the original function is x squared.
So it'd be, hold on, wait, what's the format? Like, how do we go from normal to prime? Oh, wait. Okay, so it'd be 2x.
Exactly.
Okay.
5 seconds, right?
Yeah.
Okay. This is the 5-second method using the power rule. This is the 5-minute method using the limit process.
Right, so let me get a picture of this.
And this limit process only gets harder. I gave you 2 of the easier functions.
Yeah.
When you start having functions like 1 over x, it is really more complicated algebra. And if we had time, I would go through one like that. We might have time. You want me to do one like that?
I just want to talk over this part on the right-hand side, the 5-minute method, because I don't know if I really understand it. Can you just explain like how it works?
Here's the key. When you're using the limit definition, you got to figure out what f of x plus h is and f of x. Well, they usually give you f of x. So all you have to do is this step here, f of x plus h. Once you get that, then just substitute. Whatever you got for f of x plus h, substitute there, and resolve this. In other words, this is a classic limit problem where you start out with 0 over 0, and you don't end up with 0 over 0. You ended up with 2x.
Yeah.
And that is indeed the limit, the derivative of this function x squared is 2x. So we got it the hard way, but we also got the same thing the easy way.
Yeah.
And the hard way, they can get much harder than the one I just gave you.
Yeah. So, okay.
Now, let me have a look at these on this page to see whether or not any of them are particularly hard. Yeah, 22 is going to be hard. Why? Because the x is in the denominator. Should we do 22 real quickly?
Yeah.
You have time?
Yeah.
Okay. So here's f of x. And it helps if you put stuff, not when you're doing the limit definition. We'll leave it like it is. 1 over x squared. If we were using the power rule, then we would want to write this x to the minus 2. We're not using the power rule, so we're going to do the limit definition. First step, what's f of x plus h?
F of x plus h would be 1 over x squared.
Well, keep going.
Plus h.
Actually, you don't want to distribute it, believe it or not. You want to leave it like that.
Okay, gotcha.
Okay. So now, remember, this is our definition.
Wait, can we just pause? Let's pause for 1 second.
Let
me just look at this.
I'm not going to erase anything. I'm just writing the definition of, that's the limit definition right there. And in order to answer this, we need f of x and we need f of x plus h.
Yeah, okay.
Okay? Now, let's plug it in. F of x plus h is 1 over x plus h squared. I'm going to leave that like that for a second. Well, f of x is 1 over x squared. That's just the numerator. we still have a denominator of h. You with me?
Yeah.
Now, the next step is the tough one. We have to operate on those fractions. You have to know how to subtract this 1 over x squared from this. How do you do that?
So you'd have to multiply you'd have to get the denominators of those two fractions the same.
A common denominator, exactly.
Yeah.
Well, the common denominator, I'm gonna write it over here on the left. And I'm just looking at the numerator here. Common denominator's got to be x squared times x plus h squared, correct?
Yeah.
And that's what you have to do, believe it or not, and that's why this becomes extra tough. Now, what is the left numerator of the numerator?
So it'd be x squared.
And what is the right numerator?
X plus h squared.
Now, and remember, all of this is being divided by h. So, we want to operate on the numerator. In other words, now we have to expand that. So here's the new numerator. I'm going to start it over here in the lower right. This is the numerator of the numerator. And when I expand that, it becomes x squared plus 2xh plus h squared. The common denominator was this, x squared times x plus h squared. And the entire denominator was h. Now, I'm going to have to erase some stuff to continue. Well, yes and no. Let's look at the numerator of the numerator. Remember what I said is that every term that does not have an h in it is going to go away. You see how that works?
Yeah.
In other words, that x squared is going to be lost by that x squared. You do have to apply this negative sign to every other term. So that becomes a minus 2xh, and that becomes a minus h squared. Now I can get rid of that. And now notice that is all I have left in the numerator is stuff with h's in it.
You can pull out an h.
So I can actually, if I put a 1 under that h, flip and multiply, then that h cancels with that h and that exponent, such that I have the following, and I apologize, I'm going to have to make some room here. So now here's what I have in the numerator. Minus 2x minus h all over x squared times x plus h squared. You with me?
Yeah.
Now, let's take the limit of that as h goes to 0. Remember, that's always the initial condition, is we're taking the limit of that as h goes to 0. What do you get?
So you just plug 0 into that equation that you just wrote?
For h, exactly. Which
h,
is
so
minus 2x in the numerator. And it gives you x to the 4th in the denominator.
Yeah.
Okay,
So just
now simplify. We can get rid of that x, make that third. So our answer is minus 2x to the minus 3.
Oh, okay.
That's our derivative that we got doing it the hard way.
All right, gotcha.
Now we're going to do it the easy way in 10 seconds. The original equation was, instead of writing 1 over x squared, I'm going to write x to the minus 2. Same thing.
Yeah.
Now use the power rule. What's y prime? Start with the exponent, multiply it by the coefficient.
Negative. Oh my gosh, yeah, negative 2x to the negative third.
5-second method versus the 5-minute method.
So when do you have to do the 10-minute method?
Only when they ask.
Okay.
That's it. Once you get past this in calculus, you won't have to do it again.
Gotcha.
Like I said, why they start you out on the expert slopes, I'm not sure, but they do.
I don't know.
To me, it would make sense to teach calculus by teaching you the power rule right off the get-go, and then there's a product rule, quotient rule, and chain rule. But between those 4 rules, you can differentiate any function, no matter how complicated.
Can we go over the...
Go ahead.
Quote. Can we go over those other rules you said so that I can do it all without ever having to do
We can. I don't have any problem with that because you're going to get to it soon enough anyway. I mean, it comes almost next. Okay?
Okay, yeah.
Everybody hates this limit process. So everybody's very anxious to get off this. And the next thing they teach you is the power rule, and then the product rule, and then the quotient rule, and then the chain rule. Yeah, I'd be happy to teach those to you, for sure.
Okay. Awesome. Yeah, because he's not going to take off points if I do them in another way, as long as I get the right answer.
And the advantage of knowing how to do it the easy way is you can always check your answer. In other words, if you do it the hard way and you did not come up with this answer right here, you knew you did something wrong. That answer has to be minus 2x to the minus 3. And you saw how hard it was to do the hard way. This one was particularly hard because it involved x in the denominator, and so it was difficult to subtract those 2 fractions without some high-level algebra. These problems tend to be difficult not from the calculus, but from the algebra perspective. Cade, I'm going to let you go for now. And next time we get together, I have no doubts, be working on those other rules.
Okay. You have another thing to go to right now? You have another on the schedule?
I don't.
Can we pop
a spot?
Can we do it right now?
Yeah, sure.
Okay. That'd be awesome. Yeah, I don't have anywhere to be. I just thought for some reason you had another one.
Well, I did, but it got canceled. Yeah, no, I was fully booked, and then my 4 o'clock canceled. So, all right. Power rule. You already know that one.
Yep, that's what we just did.
Product rule. Sometimes you have a function that is the product. Have you done derivatives of trig functions yet?
Derivatives of trig functions? No. We just got started with derivatives.
Okay. See if I can think of a good one here. Yeah, let's look at this. Let's say you wanted the derivative. And always remember what derivative is. It's the slope of the tangent line. That's what derivative is. And slope is the instantaneous rate of change of that function. In other words, if I look up here, that function right there is changing like that. Down here, it was changing a little more rapidly. So the first derivative of that is going to be larger than that first derivative. They're both slopes. That's what first derivative means. It's the slope of the function at that point.
But I'm confused because when it gives you an equation, are we going over 25 to 32 now?
No.
We don't have to. I was just asking. Okay,
Product.
let me ask a question. Okay, let me ask my question as I was going to. Then I was just wondering.
Okay.
So like when it just gives us an equation in like 11 through 24, it doesn't give us a point. So the tangent line could be anything really.
And that's better because the slope of the tangent line does change. In other words, if this is my function, notice that the slope of that tangent line starts out high, and then it flattens, and then it flattens further, and then it flattens further. So the slope of the tangent line is a function of where you're at on the x-axis. So when you take the derivative of a function, you want a function in return. That function that you get will tell you what the slope is of the original function at any point. Let me be a little more clear here. Let's take that function we were looking at, x squared. That's a parabola. You've been dealing with this parabola for ages. Okay?
Yep.
So, I want to know what the slope is anywhere on the x-axis. Well, if I take the first derivative using the power rule, I get 2x. Now, what's the slope when x equals 1? Plug it into the derivative function.
When x equals 1, oh, it'd just be 1.
It'd be 2. The derivative is 2 times x. So that means the slope right there is 2. Now let's go up here where x equals 4. We can see that that's a steeper slope. Oh, what is it? What is the slope when x equals 4? Plug it into the derivative function. Yeah. So this derivative function tells us what the slope's going to be no matter what x you want to talk about. What's the slope when x equals 0?
0.
Yeah, and we can see that that's true. That's a 0 slope tangent line. What's the slope when x equal minus 2?
So it would be -4. So, but when you say the derivative is basically the same as finding the slope of the tangent line, it's really the equation of the tangent line, right?
No, that's something different.
Oh.
Let's do this problem, number 25, because that's what you're asking, is how you come up with the equation of the tangent line. Well, it's not as hard as you think. It's kind of the definitive thing to do in calculus. Okay, so here's our function. Whoops, excuse me. Didn't mean to put the derivative. Here's our function. X squared plus 3, correct?
Yeah.
They want the slope, the equation of the tangent line at this point. So the first thing let's do is figure out whenever you're trying to come up with equations of lines, the most powerful thing is slope, correct?
Yeah.
Okay, so let's figure out what the slope of that tangent line is, and then we'll proceed from there. So take the first derivative, just use the power rule.
Okay, so it'd be 2x.
Yep, the 3 goes away. The derivative of any constant is 0. Okay. Now tell me what the slope is when x is 1.
2.
Okay. So we know the slope of our line, right?
Yeah.
And you have point slope format. Y minus y sub 1 equals the slope times x minus x sub 1. I don't know if you remember this from your algebra days, But there's a couple of formats. There's y equal mx plus b. But for calculus, point slope works a little bit better. Why?
Yeah.
Because you always have a slope, and you usually have a point. Well, here's our point, and we just calculated our slope to be 2. So let's plug it in. We got y minus, y sub 1 is 4, equals the slope, which we just calculated to be 2, times x minus the x sub 1 point, which is 1. There's your answer. That is the equation of the tangent line, which is not the same as the slope of the tangent line. In other words, first you got to come up with m, but then you need another point. You need a point to have point slope.
Yeah.
So let's do another one here. Let's have you do it this time.
Is this okay? Is this relating to the product rule, or did I take us on a different?
It isn't. Well, I was starting on the product rule, and you redirected me back to these. And
sorry, I didn't.
Well, that's okay, because this is probably more important at this point. Being able to come up with the slope of a tangent line at a point is huge.
Yeah.
Let's do 26, and then if we still have time, we can get to the product rule. Product rule and quotient rule are really kind of easy. They're a little bit like the power rule. So they're not tough. Whereas the concept of this, this is more the quintessential question for calculus. Give me the equation of the tangent line. Okay, so let's at least do one more of these. This is going to be as helpful to you as working on the product rule. So, when you don't know what to do to begin a calculus problem, you take the first derivative. What's the first derivative? Use the power rule. Yeah, use the power rule.
Use the power rule. So it'd be 2x.
You basically can differentiate each term separately. In other words, the derivative of a 3-term polynomial is the derivative of each one added to the other.
Okay.
So I can take the derivative of x squared and then the derivative of 3x, which is just 3. The 4 goes away. There's my derivative function.
Okay.
Now remember, my first goal is to figure out slope. So I got to figure out the slope at our point. Well, there's our point, minus 2 comma 2. So let's figure out what the slope is at the x value. What is it?
At -2 it would be -1, or it would be -1, yeah.
Okay. Now, take that, plug it into the point slope equation, the general format. What's the general format of point slope?
Point slope would be mx sub 2.
That's slope intercept. There's 2 standard formats of a straight line. And you're always dealing with a straight line here. Because when they say the slope of the tangent line, it's always a straight line. Okay? So the format that you're going to want to use in calculus all the time is the point slope format. Which is, what was it? You remember I just wrote it?
Point slope format, yeah. So, y2 minus y1 equals x2.
It's not y2 minus y1.
Oh, what am I doing?
y1 because we only have one point. This is our point. That's x sub 1. That's y sub 1. Okay, so the first thing we need is the general format, which is that.
Yeah.
Now, if you forget the general format, notice that slope is rise divided by run, right? In other words, if I divide both sides by x minus x sub 1, I get slope is rise divided by run.
Yeah.
Okay. Now plug in everything we know. We know that, we know that, and we know that. Once we plug in those three numbers, we will have their answer. So what is it?
I don't know how to plug those in. What are we plugging them in?
Here's our point over here. Our point is -2, 2.
Oh, so we put in -2 as the x value.
Correct. And +2 for the y value.
Yeah.
What was the slope? -1.
Yep.
I'm going to go ahead and write it just for clarification's sake. Minus a -2 is the same as +2. There's the equation of my line. Now, you might say, well, don't you have to simplify that and put it into y = mx plus b format? And the answer is no, you do not. This is the standard format in calculus, is point-slope, not slope-intercept. You put this in slope-intercept, and you might have a teacher actually make a comment to you that will say, you don't need to put it in slope-intercept format. You can leave it in point-slope. Notice that you get point-slope in one step. In other words, you go from the general formula to your final answer without doing any algebra. You don't need to distribute the -1. You don't need to move this -2 to the other side. This is your answer. That's why point slope is so valuable and used so much, is because it's a one-step answer to these questions. Let's do one more.
We can go on to the product rule, I think.
Okay. All right. I'm going to write the product rule in general. You may not understand this, but I'll give you an example. If I have two functions that are multiplied together, that's a little harder to take the derivative of. Believe it or not, my derivative is the first function times the derivative of the second function plus the reverse, the derivative of the first function times the second function. Okay, let me give you an example. And both a and b have to be functions of x.
Yeah.
Let's say that's my function. I cannot perform that multiplication. There's no way to get the x multiplied by the square root of x plus 1. So, in other words, I can't multiply those two together, so I have to use the product rule. I have the product of that function times that function. That's what I'm looking at. So, y prime. Well, first of all, let's rewrite y. You're going to find that radical signs don't work very well in calculus. What works really well is exponents. So I rewrite it to look like that. You with me?
Yeah.
Square root of x plus 1 is the same as x plus 1 to the 1/2 power. Now let's apply the product rule. Well, the product rule says you start with a, that's x. Then you take the derivative of b, so I'm going to use the power rule on b, which is 1/2 times x plus 1 to the -1/2. That, I just took a times the derivative of b. Follow it?
Yeah.
Okay. Plus, I got to do the reverse. Well, what's the derivative of a? What's the derivative of x? 1.
Derivative of x would be 1. Oh, yeah.
Just its coefficient. Times the other thing, not the derivative of the other thing, but b. Well, b was x plus 1 to the 1/2. So there is our answer for the first derivative. Now, can I simplify that? I suppose. What do I have? In the numerator, I Now let's see. I don't know that I need to simplify it. I don't really, but I will for you. I got x there over 2 times the square root of x plus 1. Sometimes they want you to put it back into radical format plus the square root of x plus 1. So there would be the final answer if they wanted it in radical format. If they were okay with exponential format, then that's your final answer.
Okay. What example are we doing right now? Are we on a problem, or did we just?
We're doing this one right here. I made one up because I don't see any on this page that's product rule.
Yeah. Awesome. Okay. Just
Okay.
making sure.
So I'm making one up. Now.
So when do you know when to use the product rule? Like, how would you?
Can't multiply a times b. In other words, if my function was this, I could use the product rule, but it would be silly. If I multiply them together, I get that. And now if I want the derivative, it's 5x to the 4th.
Yeah.
Okay? So you don't use the product rule wherever you can. You use it only where you have to. In my example that I gave you, you cannot multiply x times square root of x plus 1. That's as good as you can do for simplifying it. So to take the derivative of it requires this product rule. Now, let me think of another one, and this is just as important, is trig functions. I'm going to tell you the derivative of one trig function. Just give you a starting spot. The derivative of sine is cosine. Okay?
Yeah.
Okay. So let's take a function like the following. Again, I got the product. That is a function of x. That is a function of x. And I cannot multiply them together. I've got them as simplified as I can make them. So if I want y prime, I've got to use the product rule. Remember what the product rule said. If y was equal to some quantity times another quantity, then y prime is equal to a times b prime plus the reverse, which is a prime times b. So let's apply that to this x sine x. So let's do this step right here. What is a b prime?
AB prime would be x times, would it be inverse sine of 1? Or inverse?
Over here, there's the derivative of sine.
Oh, right, sorry, okay.
That's why I gave it to you, so that I could use this function. In other words, you need some derivatives of trig functions kind of to learn the product rule. I had the other problem, but it's actually easier to learn using a trig function. Plus the reverse. In other words, plus this part. There's always two parts to the product rule. You have the first part, which we just did. Now I got to add to it a prime times b.
So it would be plus sine x.
You got it. That's the product rule in a nutshell. Actually pretty easy.
Okay.
And you're going to use it wherever you have two functions being multiplied. Now, notice that if I'm adding, I don't need any of this. If I've got this, well, I can just take the derivative of the first term, which is 1, plus the derivative of the second term, which is that. So when I'm adding two terms, to take the derivative of that, I just take the derivative of each term and add the derivatives together.
Yeah.
It's when you're multiplying that it becomes problematic, and it becomes even more problematic when you're dividing. So they have something called a quotient rule, which is more complicated than the product rule.
Yeah.
Had enough for today?
So what are the rules? What are all the rules? So there's quote product rule,
Four of them.
quotient
There's
rule.
the power rule. Power rule works for a lot of stuff. And there's the product rule, which we just learned.
Yep.
Then there's the quotient rule, which is a little more complicated, but similar to the product rule.
Yeah.
And then there's the chain rule, which can be easy, but can also be hard. That's it. Once you learn those four rules, you can differentiate anything, no matter how complicated it is.
Okay, I think I'll be good for today. I will let you know when I'm ready to go over those quotient and chain rules.
That's fine. And like I said, I suspect you'll be getting to them pretty quickly.
Yeah.
All right, Cabe.
All right, dude.
Talk to you later.
Sounds good. Thank you.
Bye-bye.
Bye-bye.